of a processor. We studied in the last class, we studied some instructions in encoding. Okay, so now can you see the screen now? जी,
Yes, sir.
ठीक है, नजर आ रही है screen? Good. Okay. So now in this screen, if you see in the screen, so this is some on the right hand side. This is some program. Can you see the program?
Yes, sir.
बिल्कुल सर.
This is some program, and this it consists of many instructions. What are these instructions? Add instructions, subtract instructions. Okay, where this add instruction is stored? At which location?
सर 000.
000 में.
Add instruction is stored at location 0000. So this is then add instruction. So this is an add instruction. So add instruction is stored at location 0. The subtract instruction is stored at location 2. Multiply instruction is stored at location 4. And if you look at this in the right side of the thing, so we have some opcodes here. Can you see on the right side opcode? What is the opcode for add? 0. What is the opcode for subtract? 1.
1.
What is the opcode for multiply? 2. 0, 1, 2. So if you look, and what is the opcode for add I? What is the opcode for add I?
8.
8. So if you look at the add I, so add I has an opcode of 8. Can you see here? So the opcode field. So actually, if you remember last time, so how many fields were there? So we had 3 type of instructions. So R type, J type, and R type, I type, and J type. So the R type format, if you remember the last time, so the R type format was like this, R type. So the R type format was like this. You have an opcode field. What was the second field?
RD.
RD. What was the third field?
RS1.
RS1. And what was the last field?
RS2.
RS2. So now if you look at the opcode here, so now we have an add instruction. An add instruction, then you have R3, and then R2 and R1. So if you look at the table, so the opcode for add is 0. So the opcode for add is 0. So actually this is opcode field is 0. The destination is R3, so RD field is 3. The source one is R2, so it is 2, and the second source is R1. So this is the 0321 is the encoding of this instruction. So 0321 is in the hexadecimal is the encoding of this add instruction. Did you understand this or not?
Yes, sir.
Okay, so now we have different registers in a microprocessor. So the first register is referred to as program counter. The first register is referred to as program counter. What is the program counter? जी बताएं. What is the program counter? Program counter. So if you look at the program counter, so now we have the definition of a program counter. So this is the definition of program counter. So the program counter, can you see the screen now, beta? नजर आ रही है
Yes, sir.
screen आपको?
Yes, sir.
Okay, so I'm opening this in OneNote. So the program counter. So the program counter is here. So the program counter is a register. It is a register in a microprocessor that contain the address of the next instruction to be fetched from memory. So the address of the next instruction to be fetched from memory. So if you look at this thing, so the program counter. So let's assume the program counter contains the value of 0, 0, 0. So now let's assume that the program counter value is 0, 0, 0, 0. So it means that it contains the address of the instruction to fetch from memory. What is the address in memory? To which address it is pointing? To the first address. Okay, did you get my point or not?
Yes, sir.
Okay, now we have another register. If you look at the one node, we have another register. If you look at the memory address register, so we have another register, memory address register. So memory address register contain the address of the memory. Contain the address of the memory. So if you look at here, so this is a memory address register. It contains the address of the memory. So it is connected to the address lines A15 to A00. So let's assume if you want to perform any operation, so the address has to be loaded into the memory address register. Okay, and memory buffer register. So the other register is memory buffer register. It contains the data that is fetched to and from memory. So it contains the data that needs to be fetched to or from memory. So this is a memory buffer register. Okay, so now we want to, there are different phases of instruction. So first phase of instruction is, first phase is of the instruction. So there are different phases of instruction, phases of instruction. Different phases of, so there are different phases of instruction. So the first phase is instruction fetch stage. So instruction fetch stage, what happens? Instruction is fetched. Okay, I have a question. Who is pointing to the address? Who is pointing? G. Who is pointing to this instruction is memory?
Program counter.
Yes, very good. So the program counter is fetched. Program counter is pointing to the instruction from memory. So the in instruction fetch stage. So in instruction fetch stage. So what happens? So the MAR, the MAR. What is MAR?
Memory address register.
Yes. So the MAR is loaded with the contents of the program counter. So the MAR is loaded with the contents of the program counter. So in this particular example, what is the contents of the program counter? $00000. It will be loaded into which register? MAR. What will be the value of MAR? 000. Did you get my point? So the MAR is now the destination. MAR is now the destination. Program counter is now the source. So the MAR will be loaded with the contents of the program counter. So the memory address register is loaded with the contents of the program counter. And now this value will go on the address lines. What are the address lines? A15 to A00. So this will go on the address line $0, 0, 0, 0. Okay, so if we want to fetch an instruction from memory, so now it is, so now we say instruction fetch. So we want to fetch an instruction from memory. We want to fetch an instruction from memory. So we want to fetch an instruction from memory. Is it a read operation or write operation? बताएं?
Sir, right operation.
We want to fetch an instruction from memory. Fetch. Fetching is a read operation or write operation?
Read.
Fetch is a read operation. Fetch is a read operation. Fetch is a read operation. So now in this case, because now I want to fetch an instruction, so read write bar. So read write bar will be 1 or 0?
One.
Sir, one.
Read write. Okay. So this So this value, so now read write bar is 1. So now I'm writing say, so it's a read write bar. So read write bar will be 1 because it's a read operation. So read write bar is now 1. So when fetch and which instruction we want address we want to fetch $0000. What is the contents of the $0000? जी बताएं. Beta, what are the contents of $0000? So $0321 will go from here. So $0321 will go from here from the memory, and it will be come on the data lines because it's a read operation 0, 3, 2, 1, and it will be loaded into the memory buffer register 0, 3, 2, 1. Okay, so what is a memory address register? Memory address register contains the address of the data. It can be a data or it can be an instruction. It contains the address of the data that need to be fetched from memory or written to the memory. So in this case, the address is 0000. This address contains the value 0321. That value, because instruction fetch is a read operation, that value will come on the data lines. So on the data line 0321, and it will be loaded into the memory buffer register. So now MAR. What is MAR? Memory address register. And now MAR is pointing to the address in memory. Now what will happen? The data that you have fetched, where this data is loaded now? Into MBR. Am I right or not? The data is loaded into an MBR, which is pointed out memory, which is pointed out by the contents of MAR. So what is the contents of MAR in this case? $0, 0, 0. And what is the contents of the MBR?
$0321.
$0, 0, 3. So thus this was now an instruction fetch phase. So now in instruction fetch phase, what's done? So in instruction fetch stage, the value is now loaded into the memory buffer register. So what value is now? So now we have another instruction decode. So now we have instruction decode phase. So in instruction decode phase, now we have fetched the value from memory. Which value is fetched from memory? 0321. It goes to the address lines and it is loaded into the memory buffer register. So now we have a value of $0321 is in the memory buffer register. Okay, now we want to decode this instruction. So now we want to decode this instruction. So this phase is called instruction. Okay, so what is an instruction decode phase? So what is an instruction? Instruction decode phase. Instruction to be executed. Instruction. What type of instruction is it? What type of instruction is it? What type of instruction? What can be the type? बताएं, what can be the type? Add instruction or subtract instruction or multiply instruction. It also decides where the operand is stored. Where the operand is stored. It can be stored in the register or memory or immediate values. Okay, now in instruction decode phase, So now we have instruction decode phase. So the IR. What does IR stand for? What does IR stand for?
Immediate register.
No. IR stand for instruction
Instruction.
register. What is an instruction register? Instruction register contains the instruction to be decoded. So now, what will happen now? Which value will go into the instruction register? ये बताएं. In this particular example, which value will go into the instruction register?
0321.
हम्म बताइए बेटा. हाँ सही है. डॉलर
$032.
0. प्लीज जोर से बोला प्लीज. 3 1. So now we have an instruction register. An instruction register contains the instruction to be decoded. Correct. Okay, now if you look at this zero field, if you look at the zero field of the instruction, what does it implies? Zero field.
Add.
Sir,
It
add
is an
opcode.
upward. Okay, it is upward. What is this upward?
Add, sir.
Add. It is an add instruction. It is an add instruction. Okay, now if it is an add instruction, so which type of instruction is this? R type or J type or I type?
R type. R type.
R.
Sir.
R type. Okay, when it is an R type instruction, where the operand are stored?
Register, sir.
Operand are stored in register. Operands stored where? Stored in register. And which register? In which register? Now we have another two fields. बताएं बेटा. Two means
Sir, register addressing mode होगा ना. R2 source to.
R2. So which source?
R3.
No. RS1 is R2.
Sir, register addressing mode.
G and R1. Which register? Now if you look at this, what is this R2? RS1? Am I right or not?
Yes, sir. Right.
And R1 is
RS2.
RS2. Now if this instruction says, now we so which value should we read from the register file? कौन सी value should we read from the register file? Which
Sir,
value?
R2 और R1 की.
R1. Okay, now this R1 will go and this R2. Okay, now R2 will go into $0, 0, 0, 0, 6 will go here because it is RS1. It is for RS1. And the second value R1 will go here $0, 0, 0, 0, 4. So now we have decoded the instruction. So the next phase is instruction execution. So the next stage is instruction. Next stage is operand not operand read phase. Operand. So the operand read phase. In operand read, and pass them to the ALU unit, arithmetic logical unit, ALU unit, ALU unit, arithmetic logic. Okay, now if you look at this here, so now we have another phase, instruction operand read phase. Operand read phase. And now which instruction we are executing? This one. So it will load the contents of R2, that is $0006 operand read phase, and the second operand $0004. In instruction register we have which value? $0321 in 0321. Okay, now this is the operand read phase. This is the operand read phase. Okay, now the next phase. What should be the next phase? What should be the next phase? Beta बताएं.
सर ऐड ओके मतलब
To execute
जैसे
the instruction. Execute the instruction. Next phase is to execute the instruction. So in the operand read phase, if you look at the operand read phase, so it means that okay, in the operand read phase, now it's for R type. So for R type instruction. So now we have an R type instruction. So the R operand read phase, so the operand 1, the contents of the operand 1 will go to the contents of RS1, and operand 2 will go with the contents of what?
RS2
RS2. And in this particular example, what is RS1? In this particular example, what is RS1?
R2
R2. So this is RS1, and this one is RS2. So now we have read the operand. Now the next phase is to I'm writing instruction execute phase. So in the instruction execute phase, these operand. Okay, now what is the opcode in this particular example? What is the opcode? Beta, then
सर ऐड
add. So these two operand, it executes the instruction. Now what is the result? What is the result now? If you
सर
add
$00A
$000 now we have executed the instruction. So this is operand 1 and operand 2. And now what is this $00A? It is actually the result. So now if you look at the execute phase, execute the instruction. So what we can say, we can write it something like this. So now what is the, if you look at this result, so what is the result? The result is now equal to, what is the result equal to? क्या कर सकते हैं? Operand 1 and then operand 2, and in between we perform an operation. And what is the operation here in this particular example?
add
So the operation is add, and operand 1 in this particular example is $0006, and in this particular example operand 2 is $0004. Okay, now this is the result 000A. Now the next phase, what should be now the next phase? What should we do now? What should be the next is to what? When we execute the instruction, what should we now do?
सर इसको
If you
स्टोर
look,
करना होगा
where to
आंसर
store?
रिजल्ट को
Is to store the result.
MBR
No. Store the result. We need to store the result, not in memory. So store the result in the destination. Where is the destination now? Where is the destination now?
R5 थी
So now it means the destination for R type. So for R type, so store the destination. So for R type instruction, what is the destination? Destination is RD. Am I right or not? So
राइट सर
RD, it will be stored in RD. What will be stored in RD? What will be stored in RD?
रिजल्ट
Very good. So the result will be stored in RD. So in this example, now we have the result, and what is RD? RD is where? What is RD now in this particular example?
R3
This is RD. RD field of the instruction. So it's R3. So this $00A, the old contents of R3, the old contents will be overwritten with the new contents. And what will be the new contents of R3? Dollar what? 0 0
Zero A.
0, 0, 8.
A. Okay, so this phase of the instruction, this phase is called as operand what? So now the instruction is complete. Now the instruction is complete. What should we do now? Now the instruction is complete. Now the instruction is finished. Now the instruction is finished. What should we do now?
Sir, program counter new.
So we should update the program counter. It the program counter point to the next instruction. The program counter should point to the next instruction. So what should be the value of program counter now? What should be the value of program counter now? Program counter should point to the next instruction. The program counter should point to the next program counter plus what? What should we add now?
1.
1.
No, size of
Sir,
instruction.
size of instruction.
Size of instruction. I'm now write it in general. What is the size of instruction in this particular example? 2 bytes. So the program counter should not point to the next instruction. So initially the program counter was now. So initially the program counter was now dollar 0 0 0 0, and it should point to the next instruction. So now this should be overwritten. And what should be now the new value? What should be now the new value?
0 0
Dollar
2 हो जाएगी.
0002. नहीं समझे बेटा? ठीक है?
समझ.
So now it will point to the next instruction. So when it is point to the next instruction, this will go value will go to the MAR dollar 0002. It will point to this instruction. This value will now be moved. This value will now be moved to the memory buffer register 1CA5 dollar 1CA5. This value will now go to the instruction register dollar 1CA5. This implies that the operator is now subtract. Am I right? And now we
सर
have
आपकी
A.
आवाज बड़ी डिस्टॉर्ट हो रही है.
Okay. So okay. अभी आवाज आ रही है बेटा?
सर
अभी आवाज आ रही है सबको?
सर ऐसे आवाज आ रही है सर, बीच बीच में
सर
थोड़ी सी
आवाज
रुक जाती है, थोड़ी सी कम हो जाती है, ऐसे
मुनीब
लगता है.
मुनीब आ रही है आवाज? मुनीब?
सर पिछले मिनट में आवाज नहीं आई सर.
Acha, I will again. So now we have updated the value of the program counter. So the program counter initially was containing 0000. So it is updated, is now incremented, and it will point to the next instruction. This value will go into the memory address register. In the memory address register, it is pointed to this location in memory. The value from the memory will be loaded now into the memory buffer register. And this is now instruction fetch. This value will go into the instruction register in the instruction decode phase. And the instruction register contains the instruction to be decoded. It tells it what type of instruction is this, whether it is an add instruction, subtract instruction, multiply or divide instruction. By the instruction register, now you saw that the opcode is 1. The opcode is 1, it means that now it is a subtract instruction. When it is a subtract instruction, and it is an R type instruction. So it is also an R type instruction now. So now we need to fetch the operand. Which operand now we need to fetch? बताएं बेटा? We need now to fetch R10 and R5. So now we need to fetch R10 and R5. What is the value of R10? R10 will go to the operand dollar 0008 will go here. And now, what is the second operand? R5. This is R10. So if you look here, so this is R10. R10. The second operand is R5. So now we also need to load this 2 to the operand 2. Dollar 0002. Which operation is now this? It is a subtraction operation. Am I right or not? What will be the result now?
सर यहाँ पे तो खाली R नजर आ रहा है
Hmm?
इधर R5 नहीं लिखा हुआ 5 नहीं है
नहीं, वो नजर नहीं आ रहा, वो बेशक बेटा थोड़ा अगर नजर नहीं आ रहा तो इस कोई बात नहीं यार, इसको थोड़ा सा R5 ये देख लो। चलो
ओके
5 आपको पता चल जाएगा, नहीं 5 से आपको पता चल रहा है कि R5 है। ठीक है
Yes.
बेटा, व्हाट इज नाउ द रिजल्ट?
So 0006
$0.06.
0006, and where we need to store this?
R12
No, R12. Yes, we should go to the R12. R12. What should we know the contents of R12?
0006
So this will go into R12. So the new contents of R12 will be $000. Am I right or not?
Yes.
And now what should be the value of program counter in the next phase?
0004
0004. So the next program counter will be now 0004. So the next value of the program counter will now be, now if you look at 000, and this will go on. This will go on. Now it will go on the multiply instruction. So in the multiply instruction, now in the multiply instruction, so if we have $0004, so it will read R10 and R2. What is the value of R10? 8. What is the value of R2? 6. So R10 and R2. If you look at here, so this is R10. R10 will go here, and R2 will go here. So now it is should be the new value. Okay, now if you look at this, the state of the microprocessor is changed here. So this is $0006. If you look at this, so this is $0006, $0006, and also another value is changed. Which value is changed? R3 is changed. $000A, $000A, $A, and also R3 is here now changed. $A. So if you multiply these two, so what is the result? It is something here. So which value should we now change? What is the destination? R9?
R9
Yes, R9 will now be changed. So R9 will be updated. R9 will be updated with a new value. So this is also there. So, okay, now I'm saving this instruction. Okay, now let's assume a scenario. Now let's assume we also go to the next slide. So the next slide. This is R2. Open with Microsoft Edge. So now, if you look at this data, if you look at this, the previous data, processor 1. So which values now changed? A lot of values has been changed. Okay. So now let's assume a scenario. Now in this, let's assume a scenario. Now microprocessor points to this instruction. Microprocessor points to this instruction. Now it will point to the next instruction, which is that instruction. Add I.
006
$0006 06. This $0006 will go here. 0006 will go here. And then the value that 8625 will come in the memory buffer register. 8625 will go. This will go to the instruction register. $8625. Now there is a, okay. Now if you look at this 8 of the opcode field, if you look at this 8, What is this opcode field?
सर immediate type का add.
Add
Add
I. Add I. So in this add I, we are adding R2. R2. What is the contents of R2 now? R2 is the first operand. $006 go into here. $0006. Okay. So this is R2. So this one is R2. R2. And what is 5? This is an immediate value.
Immediate.
Immediate value. So what will be the operand value? So in this operand value, this immediate value, this direct 5 will go directly. It's not now. It's a part of instruction. The operand is the part of instruction. This 5 will go here. $0005. And these two are added. What is 6 plus 5?
B.
What is 6 plus B? 11. That is B. And this result need to be stored in which register?
R6.
R6. This register should store R6. So what is the new value of R6? $000
000B. 0B.
बैठे समझ आ गई या नहीं आई समझ?
Yes.
Okay, and then now it's very important. Now it's very important to go to the next phase. Okay, now if you look at this instruction, so what is the next program counter value? What will be the next program counter value? $0008. Am I right?
Yes, sir.
Okay, now it will go to this instruction. Now we want to study the jump instruction, so JSR level. This value will go into the memory. $E008. It will go to the instruction register. E008. If you look at E008, okay, now which type of instruction is this? J type or not? If you look at this,
J type.
JSR, J type. So it is a J type instruction. So this is a J type. So opcode is now J type. Now it is J type. When the opcode is J type, so where should we? What should we do now? It should jump. Am I right or not? If you look at the J type instruction, in a J type instruction, what was the field? If you remember, opcode. Am I right or not? And what was the second field?
Offset.
Offset. Yes. So the output is now E. And what is the offset? 0, 0,
0008.
008. No, not 0008. Am I right or not? So output is E. The offset is 0008. So now in this case, what happens? Now it happens because now the program counter should point, instead of this instruction 0008, it should point to this label. So what it does to, it loads the program counter. So this is a little bit different. So it loads the program counter. So this program counter will go into the operand A, $0008, and it will load the offset. Offset. Where is the offset? 008. These two values will be added. 0, 0, 0, and that will add. If you add 8 plus 8, so what's the result? The result is now
16.
$16. So this is 0010 in hexadecimal. Okay. Now what happened? $110. So it means $110 is now this value will go into the program counter. And the new value of the program counter is now $0, 0, 1. What is $10010? What is $0010?
Instruction I.
This is the address of instruction I. So if you look at this label, So now this is a label. If you look at here, it's a label. And label is pointing to this instruction I. And what is the address of label? What is label? What is label? आपको पता है? Label is an address.
So address.
And yes, label is an address. And how the offset is calculated? If you look at this, so now we want to jump from instruction this. We want to jump. If you look at here, $0008 now. So now if you look at this instruction, so it means that now we want to jump from this instruction. Let's assume this instruction is instruction. We want to jump from this instruction. Let's assume this instruction is instruction K. And now we want to jump from instruction K to instruction I. This instruction is instruction I. Instruction I. So how do we calculate the offset? So the offset is calculated like this. So the offset is calculated like this. So the offset is calculated like this. Address of jump minus address of not jump, sorry, address of address of label minus address of current instruction. Address of current instruction. So what is the address of label in this particular example? What is the address of label?
$0010
10 nahi, 10.
10
And what is the address of the current instruction?
$0008.
$0008. So actually this is the offset. So the offset field is positive or negative? This is positive or negative?
Positive.
Why it is positive? Because it is a forward jump or backward jump?
Forward jump. Forward jump.
Forward jump. So now in the J-type instruction, whenever the instruction is a J-type instruction, in a J-type instruction, the value of the program counter is updated. And the value of the program counter is updated by adding the contents of the program counter. So now you can see. So now if it is the J-type instruction, so we can say. So for J-type instruction, this is for normal instruction. For J-type instructions, if you look at this, the J-type instruction. So for J-type instruction, so the program counter, what will be the value of the program counter? Program counter plus what? बताएं बेटा. Program counter plus what? जवाब दे बेटा. बेटा आवाज आ रही है या नहीं आ रही? मुनीब?
Yes, sir.
आवाज आ रही है?
कट गई थी काफी ये भी.
अच्छा ठीक है.
सर अभी क्या
So it is
बोला था? उसमें नहीं आई आवाज.
So it is in a J-type instruction. So in a J-type instruction, the program counter will not point to the next instruction, but program counter will point to the farthest instruction. And how this address is calculated? The address is calculated by adding the contents of the program counter with the offset. बेटा समझ आ रही है अब या नहीं आ रही?
Yes, sir.
Very good, very good. So now it's done. So now it's done. So now if okay, now because it is a jump to subroutine, we also have to return from subroutine. So when we have to return from the subroutine, so the value of the next instruction, so the value of the next instruction, that is the value of the next instruction, is pushed on the stack. So which value will be pushed on the stack? Which value will be pushed on the stack? Because we want to return from here. The value from the push from the stack is $000A. So it means when you jump to a subroutine, you need to jump back. You need to jump back to the following instruction. So when the is a jump to subroutine, when this instruction, now it is the return from subroutine instruction. In the last, we have a return from subroutine instruction. So when this instruction is encountered, so the value that is pushed on the stack will be again loaded into the program counter. So now let's assume we have this instruction. When we reaches this instruction, $F000, F 0, 0, 0. So this F00 means it is the return from the subroutine. And the value that is pushed on the stack, which value is pushed on the stack? The value is pushed on the stack is the address of the next instruction. This instruction $00A. $000A will be then loaded into the program counter. $000A. So this strategy is followed out. This strategy is followed out for the subroutine instruction and when you call a function. ठीक है बेटा? Any question?
No, sir.
Okay. So अब I'm recording this lecture और इसका मतलब है मैं इसको already upload कर दूंगा तो आप उसको फिर uploaded lecture जो है ना देख लें. If you have any questions, so we can discuss it in the next class. Any question? Any question? जी बेटा. Any question?
No, sir.